Hello guys. In today's video, we're going to be going over what we call binomial expansion by the Pascal's triangle. And what is that? Who's Pascal? What's going on? All that's talking about is if you have a binomial. So if you have any two terms in the parentheses like this, and you're raising them to any power. This can help us with any power. So if we had something like a plus b to the power 2, I think we'd all pretty easily make a box, figure out, or FOIL, do whatever we want. We can figure out pretty easily what that would equal when we expand it. What about when we get bigger degrees though? Like a plus b to the power 5. Sure, you could make 4 boxes, it'd be a pain, be a ton of work. I propose, Pascal proposes, that there would be an easier way to do this. And that is by using what is called Pascal's triangle. So this is a long process, I would say, but it's not a hard process. So don't get overwhelmed by all the work, how much writing is going to be on the board, when it's all pretty trivial work. Everything we're doing, a lot of it isn't very mathy even. It's just a lot of work, it's a lot of writing. So what we're going to start off, this is going to seem weird, but we're going to make like a tree, like a family tree. It's going to look like, going to end up looking like a Christmas tree. And there's a very good reason why we're doing this. So let's say we have this point up here. And let's say that this is the 0th power. This tree and every point on this tree is going to split off into 2 directions. One this way, one this way. And they're going to spawn in 2 dots. You're going to get a dot at the end of every branch. And let's say this is the 1st power. This is the 1st generation of our tree. Now these 2 points, they're going to branch off again in the same directions. But this time, they're still going to branch off to the outside and generate a new dot. But when they both generate towards the middle, it's going to result in one combined dot between the 2. They're going to share a dot, and then they're going to have their own individual dot. And it's going to keep on going. So this is our 2nd power. And so let's do it again. Each dot, again, is going to spread off into 2 new dots. And if they're going in opposite directions, and there's a dot next to it, they're going to meet, and they're going to share a dot. So we have dot here, dot here, dot here, dot here. And this is our 3rd power. And we're going to keep on doing this, keep on building this tree until we get to the 5th power in this case. So this tree can go on forever. But how we're using it, we're only going to keep on making it until we get to the level of the tree that matches this number up here. So we're at the 3rd power now, so if this was to the power 3, we could stop there, we'd be done. But we want the 5th power, so we're going to go 2 more times. Oh, I just made a mistake. So this is our 4th power. And one more time. All right, and that's all we need now. So, I know that took a couple minutes. Seems completely unrelated to math. We're like, wait, why did you do that? Did you realize we're just trying to multiply a plus b by itself 5 times? What are you doing making a Christmas tree? This is why. We're going to be adding some numbers to this tree now. It's not just going to be dots. And so we're going to start off with the 1 up top. And what these numbers are going to be talking about is all of the possible ways that we can get to each of these dots by starting at this dot and only going down the tree. So it wouldn't be possible, we're not counting the number of ways to say to get to this dot where you can go like this, this, and this. Only the ways where we can go from here to here by only going down. So let's look at this dot right here. There's only one way we can get from here to here. It's by this branch right here. Same thing with this dot. There's only one way we can get from here to here. It's by using this branch right here. So we put a 1 here and 1 here. If we look at the second level, once again, there's only one way to get from here to here. It's by going straight down here. So we put a 1 here. And same thing here. We put a 1 here. However, with this point in the middle, there's 2 ways we can get there. We can go like this, or we can go like this. So we put a 2 there. And to figure out the rest of these numbers, you could keep on doing this. You could keep on counting out the number of pathways. What I propose is easier is you're using the branches that these points are stemming from. And you're looking at kind of if you're thinking about it like a tree, this would be like the root for this. And you're looking at the number for the point that is branched to the point you're looking for. So to figure out what number goes here, you're just looking at all of its branches and where they're coming from, and the numbers that are at both of those points, one or both of those points. So to get to this point, there's only one branch connecting it. It's this one, and so we put a 1 here. Since there's a 1 here, we put a 1 here. However, at this point stems from a 1 and a 2. So to figure out what we put here, we just do 1 plus 2, and we get a 3. This point stems from here and here, so we do 2 plus 1, we get 3. And then at this point again, we are having a 1, and that's going to be the trend for all of the points going along the outside, is there's only going to be one way to get there. So each one of these points, no matter how far along you get in the tree, you're going to have 1s there. So we have a 1 here. This point stems from 1 plus 3, so we put a 4 here. This point, 3 plus 3. Put a 6 here. This point, 3 plus 1. So we put a 4 here. This point, we put a 1. One more level. This point, we put a 1. This point comes from a 1 and a 4, so we put a 5. This point stems from a 4 and a 6, so we put a 10. This point is 6 and a 4, so we put a 10. This point, a 4 and a 1, so we put a 5. This point, we put a 1. So, why the heck do we do this? We have numbers now, but it still doesn't really make sense when we're talking about this. Well, this kind of tells us everything about a plus b to the power 5. So what we're going to do is, we see that this is to the power of 5, and so we're only worried about, in this case, this 5th level. This level down here that's talking about the 5th power. So the 5 levels before are meaningless to us. We have a 5th power here, so we're looking for the 5th power. And we have 6 numbers. What the heck do those 6 numbers tell us? They tell us that we're going to expand this into a bunch of different things. And each of those things are going to have a leading coefficient of 1, then 5, then 10, then 10, then 5, then 1. So what does that look like? So this thing really equals 1 times something plus 5 times something. I need a little more room. Gotta write smaller. So 1 times something plus 5 times something plus 5 times something. My bad. So we get the 1 from this right here, we get the 5 from this right here. So next on the tree we have a 10. This is plus 10 times something. For the 4th thing, we got a 10 here. So this is plus 10 times something. We have a 5 here. So this is plus 5 times something. And finally, we have a 1 at the end. So plus 1 times something. Pretty easy, right? We're just taking these numbers right here, 1, 5, 10, 10, 5, 1, and writing them 1, 5, 10, 10, 5, 1. Okay, now what goes in those blank spaces? Well, there's also a pretty easy formula you can use for that. And that tells us, first off, you have two terms in here. Figure out what those two terms are. We have an A and we have a B. So our first term is A, our second term is B. So what I'm going to do is I'm going to multiply those two by each other in every single one of these blank spaces. So in this blank space, I'm going to put AB. In this blank space, I'm going to put AB, 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 AB. We're not quite done yet. Now we're going to have to raise each of these A's and B's to different powers. How do we figure that out? Well, you're looking once again at this power up here, which is a 5. That tells us that the power of the first term in the first blank space is going to be 5. So the first A value is going to be raised to the power of 5. And then after that, you're going to use what you learned in preschool and count down from 5 to 0. And you're going to label the following A's to those degrees. So this is A to the power 5. So the second one is going to be A to the power 4. The third one is A to the power 3. The fourth one's A squared. The fifth one's A to the power 1. And the last one's going to be A to the power 0. And you're going to do the opposite now for the B's. You're going to start at 0 and build up to 5. So this is going to be B to the power 0, B to the power 1, B squared, B to the power 3, B to the power 4, B to the power 5. And that is it. There will be times where it gets a little more complicated, which I will be doing in another video, where you get something like 2x plus 1. But you could still, every single time, use this general formula of your expanded equation is going to look like this. You're just replacing the A's with whatever the term is here, and the B's with whatever term is there. So this is a general formula you can use every time if you're considering that A is just the first value in your binomial and B is just the second value in your binomial.